Hey guys, and welcome back to another video. In today's video, I'm going to be explaining the difference between mutable and immutable data types. This is an extremely important concept. It's fundamental to any programming you're going to do in Python. This is completely different from most other languages. So even if you think you're a good programmer, maybe you program in Java and C and you're here to learn some Python, make sure you watch the entire video and understand this, because this is not something you would have learned before in other languages. This is what makes Python distinct, different, obviously a lot of other factors as well, but this is completely different from other programming languages, and it can cause a huge headache if you don't understand it. So make sure, if you do not understand it, you watch through the entire video, because I'm going to be explaining it in depth, and it is really a fundamental concept. I can't emphasize that enough. When I started programming, I really wish, at least with Python, that I learned this right away, as it would have saved me a lot of time and made my life a lot easier. Anyways, let's go through. So what is a mutable data type and what is an immutable data type? Well, mutable, let's type it out here for you. Oops, so it was supposed to be a comment. I don't know how I ended up hitting that. Okay, mutable stands for changeable, and immutable stands for not changeable. So our mutable data types in Python are list, we have a set, and we have a dictionary. There's a few other ones, but these are the standard built-in data types that are mutable in Python. Our immutable data types are everything else. So everything else would contain like ints, strings, I don't know, what else do we have here? Floats, tuples, and so on. There's obviously a lot of other data types. I won't type them all out. Okay, so let's just see an example here, a difference. Like, how does this work? What's the difference? So pretty much, I'm just going to create X. I'm going to make this equal to string. I'm going to say Y, and it's going to be a new list. It's going to have 1 and 2 in it, like that. Now, I will just type them out for here. So the type of X obviously is a string, and the type of Y is a list. So you can see that our list falls within mutable data types, and our string falls within immutable data types. So let's see what the main difference here is. So I'm going to show you what we can do. So with a list, I hope you know that you can do stuff like .append. So I can say y.append, let's append 3 to it. If I print y, then y is now equal to 1, 2, 3. I can do things like y1 equals 7. Print y, you can see we get 1, 7, 3. Now notice I didn't have to say y equals y1, or I didn't have to say y equals and then print the list again like 1, 7, 3, something like that. All I had to do was just say y1 equals that, or in like .append simply. Okay, so with our string now, let's see if we can do the same thing. So I'm going to say x plus s, and you can see that it gives us strings like this. So now let's see if I print x. Well, it's still equal to string. By doing this plus s here, this returned to us a new string with a added s to it, whereas it doesn't actually change the value. So if I do something like y1 equals 7, it doesn't return to us, we don't get anything printed underneath it, it doesn't return to us a new list with the changed values like 1, 7, 2. It simply changes this original list. Now let's do some examples of alias and cloning, and I'll talk about what that is. Alias just means another name for, and cloning means like to copy. Okay, so an alias of a list, and this works for all mutable data types like list, set, dictionaries, is if I do something like this. So I say lst equals y, and I can print y, and I can print lst, and we can see they are indeed the same. Now I'm just going to close this and open it up because I don't like working at the bottom of my screen. Okay. So actually, I'm going to have to do this again. So I was going to say list equals 1, 2, 3. Let's say x equals lst, right? So I print x and I print lst. You can see they are indeed the same. So now let's see what happens if I change x. So I'm going to say x.append 8, like that. So now we should have a list that says 1, 2, 3, 8. So I print x and I get 1, 2, 3, 8. Now list, I didn't do anything to list. I didn't change list. So it should just be equal to 1, 2, 3, right? So let's see if I print list. But it's not. It's equal to 1, 2, 3, 8. Now, why did that happen? Well, when we assigned the value of lst to x, we simply created an alias for this list, meaning that we just created another name for it. This line is completely useless. It doesn't really change anything in memory, and I'm going to show this later with like a little drawing example to make it more clear. We've simply just said, okay, x is equal to this list. So whatever we do to this list is going to change X as well, and whatever we do to X is going to change this list as well. They simply are the exact same object, so any operation we do on that is going to apply to both of them, because we created an alias by simply just doing this like assignment like this. And you can have as many aliases as you want. So I can say like y equals lst, print y. I'm going to do y dot append, oops, like that, 100. I print x, y, and lst, and you can see they're all equal to the same thing, like that. Now let's watch it how this works with strings. So immutable data types, not mutable data types. So I say x equals, oops, equals str, and I say x, or let's say y equals x. I can print x, I can print y. You can see we get str, and now if I do x plus equals like 5, I'll print x and I get string 5. Now if I print y, we just get string. So the operation that I applied to y did not actually change x. It did not change that value. That's because these types are immutable, meaning that you can't change them. Same thing with numbers, right? So if you do like x equals 5, y equals 6, like this, or what am I saying? Okay, let's say y equals x, like that, and then you do like x equals x plus 5, and you change it, and then you print y. Well, y didn't change. It's still equal to 5, whereas x is equal to 10. And that is the main difference between mutable and immutable data types. One you can change, one you cannot. So now I want to get into like a memory model for these that's going to explain it a lot more clear. So I have like a little drawing tablet thing that I got recently. Excuse me, my handwriting is absolutely atrocious, so there's probably going to be some symbols or letters you might not be able to make out, but just bear with me. This is one of the easiest ways that I can kind of explain it to you guys. So I'm just going to do this, screen sketch. All right, so now it brings up this thing, so let's make sure this is working. All right, okay, so I'm just going to go to pen here, and I'm just going to draw like a standard thing that I want to call the memory model in Python. This is what is actually happening in your computer when you create lists and you create like integers and all that kind of stuff. So we created a list here, lst is equal to 1, 2, 3. So what this has done now is it's pointed, lst points to a list in our memory that looks like this, 1, 2, 3. Okay, so it points to that list in memory. And it actually doesn't quite point to that list, but I'll talk about that after. This is just the easiest way to explain it. Okay, and x now, so x is equal to list. What this actually does is it points to the same list, right? So it makes sense. They point to the same list. Now I'll show you down here when I created a string and when I said y equals x. So when I create the string x, what happens is we come up here and we have a string and it's equal to like str, like that, and that's going to be x. And I'm just going to put x lst. Sorry, I should use different names for these, but you can see. So that's the value of x and lst. This is the value of x. Now when I say y equals x, well, what actually ends up happening is I come here and I point to a new string that's equal to str, like that. Again, sorry about the awful handwriting, but you get the point. So rather than these immutable objects pointing to the same object, we point to two different instances of string. So that's why when I add a 5 here, so let's say I add a 5, so let's just erase this, it doesn't actually change our other value because, well, this is its own object. So when we print that out, you can see that it doesn't have the 5 attached to it. Whereas up here, if we change, for example, this value 2, and we change this to 7, well, that changes x as well because x is pointing to this same object. And I hope that makes sense. And this is the same kind of situation for mutable and any mutable and immutable data types. So if we want to create a copy of something, I'll show you how we can do that after, but I hope this gave you like an explanation of why that works. So same thing with integers. If I created like, let's say like x equals, or whatever, I'm using x, but anyways, x equals 6, then we get 6 here, and I say y equals x, then we get another 6 here, and you can see that we point like that, and we point like that. Okay, so we get 6, 6, two different 6s. We're not pointing to the same object, whereas with this list, that is precisely what's happening. Okay, so I made a bit of a mess here, so let's just go ahead and close this out and go back to typing some of that stuff out here. So what I'm going to do now is I'm going to bring in, like I have another file that I was writing here, and just show you some examples of how we can kind of use this property. So I have like a little summary of kind of what went on here. So immutable types, immutable data types. And of course I've closed that. Just give me a second, guys. I'm just gonna reopen this. Okay, so I've got the file back up. Sorry about that. Anyways, we have change list and copy list. These are two functions, and then we just have some operators down here. So you can see here what's going to happen. So I'm just going to actually call these functions down here to kind of illustrate what happens. So this first function, change list, simply appends 100 to a given list. You can see it doesn't return anything. All it does is it says li.append 100. Okay, so what we have to do is we're going to pass it a list. So I'm going to say change list, and we'll just do like 1, 2, 3. Or actually, I have to do like this. Otherwise, we're not going to be able to track what we're doing. So x. I give it x, and then if I print x down here, and I'm just going to comment out all of this so that we don't get that printing instead. What happens here is I'm going to print x. So you can see if I do this, I get 1, 2, 3, 100. So again, this is the same thing that I was talking about before. When we say with the parameter, the way parameters work in functions is whatever the past value is becomes equal to this name. So li, this is doing exactly this. Li is equal to x. That's simply all that it's executing. Li equals x. So when we pass x in here, it says, okay, li is equal to x. Well, that's 1, 2, 3, and they're the same object. So when we change something on li, we're effectively changing x as well. Now I want to show you what happens when I do copy list. So this copy list, and I haven't talked about what this does yet, but I'll do it in just a second. I'm going to change this to copy list and print x. Okay, so actually I'm going to say I have to say x is equal to copy list here. Okay, so what this copy list does is it creates a copy of the given list. So we say x equals to li here again, and then we're saying new list is equal to li square bracket colon square bracket. Now what this does is it makes a copy, so a new object of our list. It's no longer now pointing to the same object. They're pointing to a different object in memory that are just like identical. Okay, so I hope that makes sense. I'm going to explain this more with another like drawing thing after. And then we're appending 100 to that new list, and we're returning that new list. So let's now run the operation here. So say x equals 1, 2, 3, copy list, print x. So we get 1, 2, 3, 100. But if I say, oops, let's just do y here and print xy. Otherwise, we're not going to be able to see. So x is the original list, y is the change list. You can see that we have 1, 2, 3, which was our original list that we passed in, and then our new list, 1, 2, 3, 100. And notice that 100 is not added to the old list because we simply copied it. We did not actually change that original list. Okay, so now I'm going to talk about this is operator, and what this does is it allows us to check whether two items are the same within memory. So what I was telling you before was somewhat a lie, somewhat true. I was telling you that when you create a variable, say like x equals 1, 2, 3, it points to a location in memory where we have 1, 2, 3, just a list 1, 2, 3, and that's it. That's not completely true. What happens is actually each of these objects have an ID associated with them. You can see I'm printing ID like this. And the ID is like the actual specific location in memory. So I'm just going to get out my tablet and start drawing again. Okay, so I've got everything set up pretty well now. And what I want to do is I'm going to redraw that memory model that I was talking about before, except we're going to change a few things. So we're going to go to this LST here. And remember how I was saying that everything is actually in ID. It's not actually the value. So this is the value right here, like 1, 2, 3, right? But what's actually going to be stored in this memory model when we create list is an address. Now this address is known as an ID, like what I have down here. So the ID will look something, not really, but it's going to be like a big string of numbers. So I'm just going to say 0, 1. Okay, now this is an ID. This is obviously not the value 1, 2, 3. Now this ID points to a value. So let's just change colors here so that we don't get too confused. This 0, 1 points to a value that's going to be this list. And once we start going further than this, it kind of gets a little complicated, but we have 1, 2, 3 like this. And this ID points to that value. So when I create an alias, so like what I've done here, let's change back to red. What happens is this LST here is given the same ID. So these lists, so LST points to 0, 1, and lst2 also points to 0, 1. Now, once we have 0, 1, 0, 1 points to 1, 2, 3, which is that value. And that is known as the ID. And that's what you can get by doing this little function here that I'm going to talk about, ID, and then whatever item or object, whatever, variable name. Okay, so what this is operator does, and I'm going to demonstrate this with code, is it checks to see if these two IDs are the same. So rather than doing something, and I guess I'll write down here by doing like 1 equal to 1, which is comparing that the values are the same, we're checking if the ID is the same. So if I say 1, okay, let's actually just erase that and do like a better example here to kind of show you how this operator works. So what I'm going to do is I'm going to create X, and make that equal to, let's say like 1,000. I'm going to say Y is equal to 1,000. Now, if I were to do something like X equals Y, well, that gives us true, right? Because they are the same value. But if I were to say X is Y, that's actually false. Now you'd say, well, what? Like 1,000 is 1,000. But the thing is, remember what I was saying, that we're pointing to different objects when we create the variable. So when I create X equals 1,000, what ends up happening is we come up here, we get an ID that looks like 0, 2. Okay, and this ID now points, let's draw another black line here, to 1,000, like that. Okay, so boom, we're pointing to 1,000. All right, now when I create Y, well, same thing that I showed before, Y comes up here, and it's now actually created to an ID that's 0, 3, and 0, 3 simply points to the value 1,000, like that. Okay, now I know we're getting a bit confusing here, but try to follow along. So when I say is X equal to Y, well, we go to the ID, we say, okay, so 0, 2, that's 1,000, 0, 3, that's 1,000, these are the same, boom, correct, they are equal to. But when I say X is Y, right, we go just to the IDs. We don't care about the value when we say is, we just care about the IDs and say, well, this ID is 0, 2, this one here that I'm underlining, and this one here is 0, 3. Now, are those the same? Well, no, they're not, so obviously, this is going to return false. Now, when we do something like list, okay, so I have LST and LST2. So just go say LST is LST2, like that. Well, what do you think that's going to return? Well, LST has an ID of 0, 1, and LST2 also has an ID of 0, 1. So that gives us a true value, like that. Now, when you create a copy, and I guess I'll just show this, I'm going to clear the screen here just because I have a big mess. Create another like standard memory model. Okay, when I create a copy, so I say LST, so LST, and then that points over here to, we have again our list, which looks like 0, 1, 2, or what am I have? 1, 2, 3. Okay, you know what? Just pretend that says 1, 2, 3. I don't feel like writing it again. And then I say LST2 equals LST. Those point to the same thing. But when I say LST3 equals LST, and then we have this little colon thing here, and I'm just skipping the IDs just to show you here. What ends up happening is you say LST2 points to, and then we actually create a new list. So again, a new ID, and we get, well, 0, 1, and 2, like that. So these are no longer pointing to the same object or ID. So you can imagine this as like ID1, ID2, but simply these IDs are unique and they point to the same object, like that. I hope that makes sense in terms of like when you make a copy, you get a new ID with the identical value of whatever you're copying. So new ID for this list, like that. Okay, so that's all I'm going to be doing with the drawing. I know you guys are probably tired of seeing my horrible handwriting. So let's go back to coding where I can't make it look that bad. Okay, so now we're back onto the keyword. So what I'm going to do here is I'm just going to simply print out some of the stuff that we were talking about. So I don't need all these functions up here anymore. And let's just see. So we have LST equals 1, 2, 3. LST equals, or LST2 equals LST. So remember I was saying this should print true. And then we create a copy of LST and I say, well, is LST, is it equal to that? No, it should return false. So let me just prove this to you. Run. So we get true, false, and then we get the IDs. And this is what I want to talk about with the IDs now that we have these open. So we have this one, what I was talking about before, right? Since this is simply an alias, and I want this to stay open, of the other list, we get true because yes, they are actually the same list when using this is operator. And then LST3, well, that's not an alias of LST, that's a copy, so they don't have the same ID. That's false. And then I simply just print out the IDs for you to show you exactly what they look like. So LST, well, that has an ID 4943839 you can see that this indeed is the same ID for LST2, and LST3 has a unique ID with different numbers. And I'll just show you if I do something like, I don't know, ID like 259, like that. We get, that's the number, say like ID of, I don't know, let's do something like this, like STR. We get a different number. If I create X equals 94, or 95, and I ID X, we get another number, right? So these IDs are unique, and they, for, what do you call it? Immutable objects at least. But if I create, let's do another example, LST equals 1, 2, we say X equals LST, ID of X, ID of, LST, we can see that indeed they are the same. Just one more last proof for any of you that might have been skeptical out there. Okay, so that has been it for explaining immutable and mutable data types. I know this was a lot of information, and don't feel bad if you're slightly confused, but you should hopefully now have an understanding of how kind of the basic memory model in Python works. If you have any other questions, just let me know.